In this next short video in our session on introducing the JIDT software, we're going to talk about the contents of the distribution. So in our last short video, I showed you downloading the zip file and then unzipping it, and we've got the contents of that zip file now here in front of us. Let's go back to the slides and I'll start to talk you through what we've got here. Okay, so of course, first and foremost, you've got a copy of the new GPL version 3 license that the code is distributed under. If you're not familiar with new licenses, it's probably a good idea if you have a read of that. After that, the next most important component is the jar file. The jar file is the convention in Java for providing a library file for you. So that's the file that all your code is going to reference when it's using the Information Dynamics Toolkit. Beyond that, there are several pieces of documentation included in the distribution. I'll talk you through those on the next slide. The source code, all the source code is distributed for you in the Java source code folder. Most of you won't be touching that, but it's important that you know where it is. There are also unit tests in there in the Java unit tests folder. So if you want to go and change the source code, you can rerun those unit tests to make sure that everything's still working. There's an Ant build script included as well, especially for those of you who are taking a copy of the repository via Git. You'll need to run that build script to build the jar file for yourselves. And there are also several demonstrations of the code underneath the demos folder. And again, we'll come to those later in this video. So starting with documentation, there are several important pieces there. There's a first README file, which mirrors a lot of what's on the landing page on GitHub. Most importantly, perhaps though, there is a preprint of the publication that introduced JIDT included in the download. Let's have a quick look at that. So here in our top level of the distribution, there's the Info Dynamics Toolkit.pdf file, and that's the one I'm talking about. So this is a copy of the paper that introduced JIDT. So this paper gives you quite a bit of background on the different measures that are included in the toolkit, as well as how the toolkit is designed and some examples of how to use it. I won't go through the whole paper here. What I will say is a lot of the detail on the measures themselves is included in appendices. So Appendix A goes through the detail of all the different measures there, as well as little subtleties like how to compute statistical significance for the measures, and then in the next appendix, several different estimation techniques for the measures are described, and we'll go through some of those estimation techniques in our next session. Okay, you've also got a tutorial folder that gives a full tutorial presentation and some sample exercises, and the more detailed course folder, which includes all the slides that we're going through in these short videos. There's a Java Docs folder there as well, which includes HTML pages that document all the methods and various options for each of the estimated classes in the toolkit. Let me show you that very briefly. Most of you won't need to look at that. Let's open those up. So we go into Java Docs, we double click index.html. Okay, so most of you won't need to go through this, but occasionally there will be some details on a method you will need to check, and so you'll need to come in here. You can either browse by package or you can browse by class name. So let's say we pull up a transfer entropy calculator using the Kraskov estimator type. We can come in here and we can see a brief overview of the class, some references on where to find more information about it, about the measures and the techniques included. And we can scroll down and we can see detail on how to construct the measure, as well as different methods that we can call on it. For example, we can have a look at how to how to add observations using observations for univariate source and destination time series there. Probably the most important part of the documentation, if you're going to need to use it, is the set property method. So here you can look at what kinds of properties you can set on each of the estimators. I haven't really told you so much about how to call the estimators yet. We'll go through that in the next couple of videos. But in terms of documentation, the set property methods are probably the main thing that you might ever need to come and look up here. Okay, there's also PDFs describing each of our demos in the demos folder, and we'll have a look at that shortly towards the end of this video. I'd also recommend, there's a lot of wiki pages that we have on the JIDT homepage. Let's just go and have a quick look at that. So here you'll see once you've come through from the main page into any of the wiki pages, you'll see a menu on the right hand panel here of all the different many of the different wiki pages that we've got. We've described here how to get started with download and installation. We've described all of the different demos. There's links for the course and tutorial. There's how to get started in non-Java environments, and so on. Also, we have a JIDT Discuss Google Groups mailing list if you get stuck on more difficult issues. Now, to the source code structure. I don't want to go through this in detail. Again, most of you won't really need to know too much about this. But in brief, the source code isn't under Java source. It's all organized into what are called Java packages, and packages map directly to subdirectories. So what we have here is infodynamics is a folder, measures is a folder under that. This is what the package structure means. And we split the classes into estimators for discrete data and estimators for continuous data. And then we split packages again under continuous for different estimator types. So if you're looking for a particular kind of estimator, that's where you're going to find it. We also have mixed estimator types for discrete to continuous mutual information calculators and so on. As I say, I don't want to go through that in too much detail. Also briefly, in terms of how we've architected the measures, again, most of you won't need to know about this. This is for more the advanced users, but what I do want to mention, even for basic users, is that we have implemented different interfaces for our measures. So we have a common interface for conditional mutual information calculations on continuous data and for transfer entropy calculations on continuous data. The interfaces define how you can interact with all the different kinds of estimators that implement those measures. Okay, so what we have here is I'm showing the class structure using a UML diagram for our estimators using the Kraskov estimator type. Again, we will cover that in one of our later sessions. There are other estimator types here that also implement that interface class. The important thing about having interfaces is it means that you interact with the estimators in a common way. It doesn't matter what type of estimator class it is, we interact with them all in a common way. So our calculators implement the interfaces. Sometimes we have what are called abstract classes that collect common functionality, and our child classes that are our concrete classes that you will use. They inherit the common functionality from the abstract classes and implement the interfaces. As I say, most of you won't be advanced users, won't need to know all these details, but what is important for you about the fact that we've implemented using interfaces here is that it means you can swap with very minimal code. You can swap the kind of estimator you're using. So you could try something first using a simple linear Gaussian estimator, then with a one-line code switch, swap that over to using a more advanced Kraskov estimator. That implementation using interfaces, so that those estimators are all called in a common way, is what allows you to do that. Okay, the last thing I want to mention here in terms of what is included in the download are the demonstrations. We have a large number of demonstrations packaged for you. They're all under the demos folder. We're going to go through in our next short video the Auto Analyzer GUI or code generator tool, which is our most important demonstration. It's the best way for you to get started using the toolkit. There are a bunch of simple Java demonstrations. We already ran one of those in our previous short video to check that our download was running okay. Those simple demos are mirrored in MATLAB, Octave, Python, and other languages like R and Julia and Clojure as well. They're all under the demos folder here. Let's just have a quick look at that. Under our demo folder, you can recognize the different languages here, and if we go into any one of those, you'll see the set of simple demos that you can run, showing you the basics of how to use the toolkit in that language. There are a bunch of other demos incorporated there as well, including recreating Schreiber's original transfer entropy examples and investigating the information dynamics of cellular automata and so on. All of these demos have documentation with a PDF packaged in the demo folder and wiki pages for them, and they're provided to help you run them there and show you some interesting things to do with those demos as well. In our next short video, we're going to go into some detail on running the Auto Analyzer GUI, which as I say is the most important demo to help you get started.